Chapter 8, Lesson 7, Hands-on. Use models to write fractions as decimals. You can use models to write fractions as equivalent decimals. Draw it. Use a model to write 1/2 as a decimal. Write 1/2 as an equivalent fraction with a denominator of 10. So this is going to be super important because our number system is base 10. Everything on the bottom, all of the denominators, when we're trying to make these into decimals, must be powers of 10. So 1/2, we're going to say we want a denominator of 10. So 2 times what gets us to 10? That would be 5. What we do to the bottom, we must do to the top. 5/10. And then if you think about it, when you say the fraction 5/10 out loud, it's exactly how you would say the decimal 5/10, because this is the tenths place, this is the hundredths place, and this is the thousandths place. Okay? So we'll shade in 5/10 using the grid. How many tenths are shaded? 5. The model shows 5/10. Or maybe I should put the word 5 or 0.5. Okay. Can't see that quite well. Just 1, 2, 3, 4, 5/10. Okay. Helpful hint: multiplying 1/2 by 5/5 is the same as multiplying 1/2 by 1. Notice that's why they sketch the 1 over it. The result is an equivalent fraction. All right, on to page 590. Try it. Use a model to write 3/4 as a decimal. Write 3/4 as a fraction with a denominator of 100. Well, we can't do 10 because does 4 go evenly into 10? No. So we want to find a power of 10 that our denominator will go into evenly, which is why we chose 100. So 4 times what equals 100? That's right, 25. So 3 times 25 is 75. And then again, when you hear that, you hear 75 hundredths, right? This is going all the way into the hundredths place. Or 3/4, or if we took this 3/4 and we split it into a hundredths grid, we have 3, 4, 5, 6, 70, 1, 2, 3, 4, 5. 75 hundredths. So how many squares are shaded out of the hundredths? 75. Because we already use these with decimals, so now we can do that same thing while working with our fractions. Talk about it. Model math. In the first activity, how would it change if 1/2 was written as a fraction with a denominator of 100? Would the result be the same? So if we took our 1/2 and we made it into an equivalent fraction of 100, 2 times what gets us to 100? 50. What I do to the bottom, I must do to the top. Okay. So if I had 50 hundredths, would I still have 1/2 of my model? Yes. It would be the same because it is still 1/2. Do 3/5 and 6/10 represent equivalent numbers? So one way to figure this out is we have 3/5. You heard the word 6/10 because we have a 6 in the tenths place. So if I want to try and figure out what the equivalent fraction is, I'm going to put it over the denominator of 10 for tenths. And I'm going to ask myself, 5 times what gets me to 10? 2. What I do to the bottom, I must do to the top. 3 times 2 is 6. So are they equivalent numbers? Yes. 3/5 and 6/10 are equal in value. See above example. Okay, and then let's take a look at number 3. If I have 2/5, what decimal will that turn into? Well, I have a model here, and there are 10 spaces, so I'm going to take my 2/5, and I know that my new denominator needs to be 10 because that's the model that the book provided, plus we need to go into powers of 10, and 5 does fit evenly into 10. 5 times what equals 10? What I do to the bottom, I must do to the top. 2 times 2 is 4. And now I take my 4/10 and I shade it in and I think back to how this relates to decimals. I have 4/10. Okay. All right, come back with questions.